Hello everyone, my name is Vaishno Prakash and I am currently pursuing my engineering from Rajkiya College, Sonbhadra. I am excited to present the project I completed during my internship at Emertex Technologies Pvt Limited. A simulation of washing machine using the PIC16F877A microcontroller. This project is a blend of electronics and embedded software and it reflects how smart appliances work under the hood. In today's world, almost every modern home appliances from washing machine to microwave ovens uses embedded system to automate and simplify tasks. The core of this project is PIC16F877A, which controls the washing process by taking user input, displaying message on screen, and managing the wash, rinse, spin cycles. I designed and simulated the complete system using MPLAB XID and compiled the code with XC8 Compiler and used PICSimLab for virtual testing. Over the next few minutes, I will walk through the full system, how it was built, and how it behaves like a real washing machine. So, coming to the next slide, I will explain every part and my teammate Priyanshu Rathore then after explain other parts. So, coming to next slide, table of content. This slide gives a complete overview of the topics covered during my internship project on washing machine simulation using PIC16F877A microcontroller. We begin with an introduction to the project objective and relevance to real-world appliances. Then we dive into the basic of embedded C programming, which is essential for writing code that runs on microcontrollers. We cover key programming elements like keywords, data types, conditional statement, which control the decision making logic. We also explore operator, arrays, functions, pointers, which help to manage data and make the code modular and efficient. After that, we introduce the concept of microcontroller and explain why we specifically choose the PIC16F877A for this simulation. I also go over the pin configuration of a PIC microcontroller and how interrupts and timer are used to handle real-time tasks. Next, we review software requirements like MPLAB ID for development, XC8 Compiler for converting code to hex, and PICSimLab to simulate used test circuits. Finally, we talk about hardware peripherals such as CLCD for displaying information, fans to simulate the spin action, a buzzer for alert, and switches used for user input. This roadmap set the stage of technical detail ahead. So I am moving to the next slide with detailed information. The next slide is about things which I learned during my internship. So during my internship at Emertex Technologies, I gained both theoretical knowledge and hands-on experience in embedded system development, starting from very basics. First, I was introduced to the C programming language, which is the foundation for embedded programming. I learned about conditional loops, operators, strings, and most importantly, pointers, which are crucial when working with memory and hardware interfaces microcontrollers. Then I explored the basic embedded system, understanding how software and hardware work together in real life. Uh, Real time to control devices like washing machines, microwave ovens, or even industrial system. I also got a clear understanding of microcontroller and microprocessor, their difference, architecture, and practical appliances. This helped me grasp why microcontrollers like PIC16F877A are ideal for automation tasks. After building the foundation, I moved on the project implementation. I applied all this learning into real-world simulation project where I wrote embedded C code, managed hardware inputs and outputs, created a working model of washing machine controller. The implementation was done using MPLAB XID for code development and PICSimLab for circuit simulation. These tools allow me to write, debug, test my code without needing physical hardware, making the learning process smooth safe, and effective. Overall, this internship not only improved my technical skills but also gave me confidence to take embedded projects independently. So, moving to the next slide, I will explain what is embedded system I learned during my internship. So, moving to the slide number 4. What is embedded system? An embedded system is an essential combination of both hardware and software that is designed to perform a specific task or function, usually as a part of larger system. So, unlike general purpose computers that can run various appliances, embedded systems are tailored to do one job, but they do it with high reliability and efficiency. For example, in a washing machine, the embedded system ensures the correct water level, speed and washing duration based on the selected mode. Embedded systems are literally everywhere around us. In telecommunication, they control devices like routers, switches, and VoIP adapters, enabling fast and stable communication. In consumer electronics, embedded system powers smart watches, smart TVs, and smart home devices like thermostats or security system. In the automotive industry, they are crucial for things like ABS system, airbags, and even the control unit for engines. In aerospace, flight control system and satellite telemetry depends heavily on real-time embedded system for safety and accuracy. Medical devices such as heart monitors and digital thermometers also run on embedded logic to ensure precise and timely data readings. And in industrial automation, embedded systems are found in CNC machines, PLC controllers, they control robotic arms, motors, and sensors. So, embedded systems are just not limited to computer gadgets, they are brain behind the intelligent behavior of almost every device we use today. So in picture you can see the real world example of embedded system like consumer electronics, automotive applications, medical devices, industrial application, telecommunication, smart devices, IoT, aerospace, defense, etc. So in this slide you have detailed know about what is embedded system. So moving to the next slide, and slide will give you introduction about washing machines. So moving to the next slide, introduction to washing machines. These slides will be explained by my teammate Priyanshu Rathore, and he will give the details explanation of these slides. So my teammate Priyanshu Rathore now explain next slide.
Hello everyone, my name is Priyanshu Rathore. I am currently pursuing my engineering degree from Rajkiya Engineering College, Sonbhadra. Today I am excited to present my internship project completed at Emertex Technologies Pvt. Limited, a smart water level controller simulation using a PIC16F877A microcontroller. This project combines electronics and embedded software to automatic water take control a practical solution to everyday water management challenges. In modern homes and building, water overflows and dry tank condition are common problem. Embedded systems can offer a smart and automated solution. Using a PIC16F877A, this project monitors the water level in a tank using sensors and controls the motor accordingly. It also displays real-time status and an LCD and provides buzzer alerts in critical conditions. I designed the entire system in MPLAB XID compiled the logic using a XC8 compiler and simulation it virtual using PICSimLab. Over the next few minutes, I will talk introduction to washing machine. A washing machine is an automatic appliance simply that simplifies the process of clearing clothes using a combination of water, detergent, and mechanical agitation. agitation. It uses a sequence of programmed operations, primarily washing machine rising and spinning to remove dirt and detergent from clothes. Instead of manual scrubbing of soaking, it uses a mechanical agitator to move clothes in soapy water, followed by a rinse cycle to remove detergent and the high speed spin cycle to extract excess water. In our project, we simulate this entire process using embedded C in the PIC16F877A microcontroller inside a virtual lab environment called PICSimLab. The key feature we have implemented in the simulation include cycle timing control, which is handled by the internal timers of the PIC microcontroller to replicate real-world delays during each stage. Motor control is simulated through a fan of LED which turns on during the spinning phase, giving a visual cue. For user input, we use virtual push button like start or stop, just like real washing machine have. A 16 into 2 LCD I used to display real-time updates such as washing, rising, or completed. And finally, a buzzer is included in the simulation to signal that the washing cycle is done. So, by integrating all these components, our project mimics how a real washing machine functions using embedded system. So my teammate discussed next slide properly.
So I am explaining the next slide. Previously, my teammate Priyanshu Rathore explains the how washing machine works. So I am discussing the previously I have discussed the what is embedded system. Now I discuss the types of embedded system. How many types of embedded system? So there are 4 types of embedded system. They are classified. First is real-time embedded system, second is standalone embedded system, third is network embedded system, and fourth is mobile embedded system. So embedded system can be categorized based on how they function and interact with the environments. So this type of system, number first, real-time embedded system. What is real-time embedded system? This type of system is designed to give an output within a strict time constraint. It reaches immediately to an event or an input. For example, the airbag system in a car must deploy within millisecond of crash. Any delay can cost lives. These systems are crucial in safety critical applications like automotive or aerospace. Next system is standalone embedded system. This system works independently and does not rely on any host system to function. For example, a microwave oven or washing machine, just like one we are simulating once programmed, these devices operate on their own, respond only to user input. Then comes to the third, network embedded system. These systems are connected to a network like Wi-Fi, Bluetooth, and share data with other devices. A great example is a smart home system where the CCTV camera, a smart doorbell, thermostat all communicate over the network. They are part of Internet of Things IoT. Lastly, we have the mobile embedded system. These are lightweight battery power system used in portable gadgets like smartphone, fitness tracker. They are optimized for energy efficiency and compact performance. Each plays a unique role in modern technology, and embedded engineers often work across all four types. So, I have discussed in detail. I am discussing in next slide what is the block diagram of embedded system. The block diagram of embedded system is shown in the slide. Firstly, we give input, and at the center of system we have microcontroller or processor which acts like brain. This component processes data, takes decision and controls all other parts. The input devices are on the left. These can buttons, sensor, switches or keypad. Anything the user environment uses to provide data. For example, in our washing machine simulation, the digital keypad attached input devices to select washing modes. Then come to the memory connected directly to the processor. There are two types: ROM, that's read-only memory where the program code is stored permanently, and RAM, random access memory, used for temporary data like variables and timers during operation. Now we have output devices on the right side. These included LCD display, LED, buzzers, fans in our project. The CLCD switch, the current mode and fan simulate the spin cycles. Optionally, we are also communicate interfaces like UART, SPI or I2C used to send or receive data with external system. All of these modules work together in synchronization. Input are read, processor interrupt them, memory stores necessary info, and output are triggered based on logic. This architecture makes embedded system efficient, task specific, and ideal condition smart devices like washing machines. So, moving to the next slide, basic embedded C. Now let's talk about embedded C, the programming language that powers the most embedded system. Embedded C is a specialized version of C language designed specifically for programming hardware like microcontrollers. It allows us to write efficient and compact code that interact directly with electronic components such as sensor, motors, fans, LEDs, and more. So, why do we use embedded C? Well, for one, it gives direct access to hardware. Unlike general purpose language, embedded C lets us control individual pins of microcontroller, which is essential in automation. So, why we use embedded C? Directly access to hardware like motor sensor uses very little memory, fast and efficient for real time task, runs on smart devices like Arduino, PIC, ARM, etc. Key elements has include it is used to import library or header file specific to the microcontroller. The main function, this is a starting point of program where execution begins. While the creates an infinite loop allow program to keep running, which is a typical embedded system that need to run continuously. Ports like port B or port D are used to control the input-output pins of microcontroller. For example, turning LED on off or reading to button press. So overall, embedded C is the heart of an embedded application, allowing us to build software and hardware efficiently. So moving to the next slide. Keywords in C. There are 32. If we talk about keywords in C, there are 32 total keywords in C. These are just the most commonly used. Some are given below. Int, declare integer for timer, speed, water level, etc. Character, store characters. If else, used for decisions. While, runs continuous. Loose, for loose for display repetition. Return, prints a functional sense and result if needed. Void defines function that returns any value. Break, exist a loop switches only when condition is met. Switch case, used to select washing modes easily. Constant, declare the fixed values. Example, maximum motor speed, default time. So moving to the next slide. Data types. Data types. Data types in embedded C. Let's now understand the data types are be commonly used in embedded C programming. These are important because they define how much memory or variables usage and what kind of data it can store, which is critical when working with microcontroller that have limited memory. So you can see the data types in the given charts. So moving to the next slides. Project requirements. Let's now talk about the basic project requirement for simulating a washing machine using PIC16F877A microcontroller in PICSimulation 8-bit microcontrollers, 40 pins, 33 input-output pins, support timers, ADC, UART, and PWM, widely used in embedded system simulation. Software tools which used in project. Number 8, MPLAB XIDE. It is used to write the compile and debug embedded C code. PICSimLab to simulate the microcontroller and washing machine models. XC8 Compiler to convert C code into machine code for PIC16F877A. So moving to the next slide. MPLAB XIDE. Now let's discuss the MPLAB XIDE, which was one of the most important tools in our washing machine simulation project. MPLAB XIDE is a software developed by Microchip, the same company that makes the PIC microcontroller. It is used to write, compile, debug, and simulate the program specially for microcontroller like PIC16F877A. So what is MPLAB XIDE? MPLAB XIDE is an integrated development environment developed by Microchip Technology. It is used to write, compile, debug, and simulate program for PIC and DSP microcontrollers. How it is used in our project? So create project, new project for PIC16F877A. Write code, develop embedded C code to control washing machine functions, compile code, uses XC8 compiler to generate hex files, debug simulate, test code, logic simulate, input output before uploading to PICSimLab. So moving to the next slide. What is PICSimLab? PICSimLab is an open source virtual laboratory used to simulate PIC microcontroller and connected components like LEDs, motor, display, switches, etc. What is the use of PICSimLab in our project? It is used to upload hex files, simulate buttons, check outputs, and debug behavior. And you can see the more detail in which I have made the table. So moving to the next slide. PIC simulation diagram. This is a diagram of PIC simulation. I will explain each and detail part how it works in next few minutes. This is a diagram and you can see heater, cooler, temperature. There are buttons that works RB3, RB4, RB5, RA5. From RB4 it opens on the system. This is a buzzer, heater, fan, etc. are simulated in this PIC simulation diagram. So moving to the next slide. This slide will explain by my teammate Priyanshu Rathore.
Now, let's talk about XC8 Compiler, one of the most essential tools used in this project. XC8 is a C language compiler developed by Microchip. It is used to convert embedded C code into machine readable hex code for 8-bit PIC microcontroller like PIC16F877A. I use in your project some tools such as task compile code. This is convert embedded C program into hex file, optimize execution, ensure fast and memory efficient code runs on PIC16F877A. Error checking identifies syntax and logic error in code before uploading to simulator. I discussed next slide. Components used microcontroller PIC16F877A. PIC16F77A key space such as PIC16F877A main controller, crystal oscillator such as 20 MHz frequency, clock source. Push buttons, start mode, door switch, LEDs, status indicators, DC motor, drum simulation, relay module, motor on-off control, buzzer, end of cycle alert. 16 by 2 LCD display was mode and time. Register and capacitor support components. 5-volt power supply, system power. PICSimLab simulation environment which is convert to code in machine. So I have discussed future in detail such as type 8-bit CMOS receives program memory 8 KB flash, RAM 68 bytes, timer 3, TMRO, TMR1, TMR2. Input output pins 33 digital ADC analog to digital converter, 10-bit 8 channel, speed 20 nanosecond at 20 MHz, package 16 pin tip and extra UART space and I2C PWM. Now I discuss next slide. Block diagram of PIC16F877A. This block diagram we discussed such component which defined the complete PIC16F877A. Let's now understand the block diagram of the PIC16F877A microcontroller, which gives us a clear picture of how its internal components work together. At the core, we have the central processing unit which execute instructions written in embedded C. It's surrounding by various functional blocks. First, we have program memory where our compile hex code is stored. This flash memory and non-volatile. This RAM, then their RAMs, which is used for storing variables temporarily during execution. The input-output ports A to E provide 33 digital input-output pins, allowing us to connect button, LCD, motors, and sensors. Next, we have the timer modules, timer 1, timer 0, timer 1, and timer 2, which help to generate precious delay and time-based operation like cycle duration. There are also analog to digital converter block which can take analog signal like from sensor and convert them into digital values for processing. Useful if we add temperature or water level sensor in future upgrades. Communication modules like USRT, SPI and I2C enable the microcontroller to communicate with external device of other controller. Finally, the oscillator and clock circuitry keep the system running in since driven by a 20 MHz external crystal. So the block diagram is not just theoretical, it shows how everything from input, logic, memory to output are integrated, making PIC16F877A ideal for real-time embedded application like our washing machine simulation. Now, next slide discuss my teammates.
So I am discussing the timers. So timers are critical part of embedded system, and pick one PICSix877A microcontrollers comes with three powerful timers: timer 0, timer 1 and timer 2. So you can see in block diagrams. So timer measures the time intervals, count the external events, PWM PWM generates for motor speed and control signal modulation. Timing terms in embedded system. Term easy meaning. Tick what tick means? One small time step like a heartbeat. Resolution. How small the system can count time. Quantum. How long one task can run before switching. Scaling, adjusting time, setting to work better. So next slide. Character LCD CLCD. A character LCD is a display device commonly used in embedded system to show alphanumeric character. CLCD stands for character liquid crystal display. The most popular model is 16:2 LCD, which can display 16 characters on 2 rows. In this project, the CLCD is used to display the washing machine current state such as washing, rinsing, or complete. Pins used in character LCD is shown in the table, such as pin RS is used for register select, RW read write, enable, D4 D7 data pins, VSS VDD ground and power, V0 contrast control. So moving to the next slide. Buzzer. What is buzzer? A buzzer is an output device that makes deep or alert sound when powered, used in washing machine simulations. What is the purpose of buzzer? End of cycle alert beeps when washing machine is done. Error notification once if door is open or water is low. Button feedback. A beep when user presses a button. How it works? Connected to the digital pin of the microcontroller, turned on off using a simple high-low signal. Can use transistor or relay for control if needed. So you can see the buzzer in the diagram. So moving to the next slide. This slide will explained by Priyanshu Rathore, my teammate.
Now let's discuss. I discussed what is a fan. Now a fan is a motor. A fan is a motor driven component used to move air in embedded system. It can control by a microcontroller to turn on off a run at different speed using washing machine simulation purpose cooling drying controlled by MCU such as how its use this is given by. Now I discuss controlled method connected to a digital pin or relay module can be controlled using PWM to vary speed. Needs external power supply in real projects. Now I discuss next slide by Vaishno Prakash.
So thank you, my teammate Priyanshu Rathore. I am moving to the next slide. So finally, next slide is conclusion. Before conclusion, I will show how it works. So moving to the XID lab. This is where I make my programming. So here we have fully built, and from this we can load hex files in MPLAB. So I have already loaded a hex file. You can load here from hex file washing machines x production.hex. I have already done. So resetting this and starting from 0. So I have reset this. Now I will explain how it works. So press key 5 to power on power supply. So I am clicking RB4 key. So it's powering started.
Now this is starting and working properly.
So you can see washing programs like daily Hybrid dedicates. So moving to the next slide, we press RB for water level. It show also water level like when we long press it show water level like auto, low, medium. So again long press and how it works. So To start the washing machine, press switch SRBW5. So program is starting now. The fan is now start.
Now our fan is properly working. This is seen by the functions pass time. This is given 38, 37, and SWS starts.
So program is completed. It show in LCD display and we remove the fans. So fans stop the working. So in this way my project is completed. So now moving to the conclusion point. So we have successfully simulated washing machine system using PIC16F877A microcontroller. This was achieved using embedded C for logic and PICSimLab for simulating the connected component like motors, fan, buzzer, switcher, and LCD display. One of the biggest achievements was giving control over real-time operation thanks to the user's use of time, input, output pins, and conditional logic. This project clearly showed how embedded system and automation efficiently precise to our everyday electronics, whether it's washing machine, a microwave, or even smart home devices. And finally, more than just theory, it requires hands-on experience from coding, debugging to simulating hardware behaviors. It extends my understanding of how microcontroller and how software hardware communicate in real time. And finally, this experience lays a strong foundation for exploring advanced topics like IoT, home automation, or even building smart appliances in the future. Thank you for Emertex Technologies for providing this valuable project. So in this way, we end the project.
Now, thank you, Emertex, for giving this opportunity to learn embedded system and deep with this program. And I have gained a project complete completed. And thank you so much.